All right, so this is the second video in chapter 12. We're going to start where we left off, talking about doing some examples of linear regression and correlation. So let's take a look at the second example here, money and placement. So what we look at, we're seeing if there's a correlation, some sort of a relationship between the money spent on a college wrestling program and their final placement in 2017. So what we did is we collected the data on the Big Ten programs. That was my sample. And we collect how they placed in the NCAA wrestling tournament along with how much they spent on their wrestling teams. So if we do that, we look at all of the expenses. We're going to use that as our independent variable. Our dependent variable is going to be their place. So Indiana spent a little over $1 million on the wrestling program. Michigan State spent a little bit under that. You can see Ohio State, Penn State spent the most. Iowa they were third on that list. So what I'd like you to do is put the expenses in list 1 and the placement in list 2 of your calculator. So again, stats, edit, and then into list 1, the expenses, in list 2, the placement. I'm going to push pause while I put this into my calculator. I would suggest you do the same. All right, so I put that stuff into my calculator. Once I have the expenses into list 1 and the placement into list 2, then I can go for a calculate linear regression list 1, comma, list 2, or xlist L1, ylist L2. Now, what that's going to do is give me a line along with a correlation coefficient. Now, in this case, the line looks a little bit different than we had previously. So the least squares regression line would be y equals. Now it gets a little bit tricky here because my coefficient on the x is actually a negative 2.66 times 10 to the negative fifth. So it's in scientific notation, that coefficient on the x. I'm going to put that in parentheses just so that we know that that coefficient, that whole number, is actually the coefficient on the x. And then my b, my y-intercept, is 61.87. All right. So correlation coefficient, r, well, this time it's a negative 7070. Or, excuse me, negative 0.7070. Now, remember, our cutoff value was 0.75. So if our R is bigger than 0.75 in absolute value, we're going to say that it's a good fit. Since this R is under 0.75 in terms of absolute value, this would be a bad fit. So we have a bad fit. So this line does not fit very well with the data. Now, just a note, this negative R value, what you'll find is because this line, because your coefficient here is a negative coefficient, that's what's leading us to have a negative R value. All right, so negative coefficient, negative R value. All right. Now, we know this line is a bad fit, so in reality, we would not really want to predict anything using this line. However, if on the test or on a homework it says, hey, can we predict this if a college team spent 1,500,000? Go ahead and do it. Go ahead and put in the actual line, and n for x, just replace it with whatever number we're dealing with. In this case, 1,500,000. All right. And when you do that, it's a little bit tricky. Negative 2.66 times 10 to the negative fifth times 1,500,000 plus 61.87. I got 21.97 as long as I type that in right. So I got that y equals 21.97. Now this is placements. Remember the y value. But still, go ahead, it's perfectly okay. The line is predicting at 21.97. We already understand that there's sort of a range of predictions what this line would come with, even if it were a good fit. Okay, so 21.97. So what that's saying is that if college programs spent 1,500,000 on their team, this line would predict to place about 21st, 22nd, somewhere in there. Okay. What if the college spent 2 million on their team? Well, we just take this exact same concept and say they're going to spend a little bit more money. So instead of 101,500,000, what if we spent 2 million on the team? Well, it turns out that if they spent 2 million, this line predicts their placement to be at 8.67. All right. So about 8 or 9. Now, again, normally in real life, you wouldn't want to predict if we had a bad fit, if our data was not a good fit. But again, if you come across a question like this on the test, or you come across anything like this on the homework, then go ahead and do your predictions, round a couple of decimal places, and we'll be good to go. All right. Now the last question says circle all values where you should not predict due to extrapolation. So our data set was just what the Big Ten teams spent in dollars. If you don't know this, Big Ten tends to have a little bit more money than some of the smaller conferences. So if you look at, for instance, the lowest amount spent, looks like Michigan State at 973,000. And what's the highest spent? Well, the highest spent was Ohio State at 2,349,000, roughly. So if we were doing this just based on extrapolation, you would not want to predict at, let's shade that red. You would not want to predict at 400,000. I'd circle that one. 800,000 also, I'd circle that one. 1,250,000, that's fine. That's within our range. Remember, our lowest number, Michigan State, was in the 900,000s. Our highest number was 2,300,000 something. So 1,250,000, that's fine. 1,700,000, that's fine. 2,250,000, that's fine. 2,750,000, that's actually bigger than what any of those programs spent. Again, we look at the lowest value, we look at the highest value, and we say anywhere predicting in there is fine. Predicting outside of there is not okay due to extrapolation. All right. So that's the idea of what a typical problem will look like. It's going to ask you to find the least squares regression line. It's going to ask you to find the correlation coefficient. It's going to say, is this a good or bad fit? Might ask you to do a couple of predictions. Might ask you to, talk about extrapolation, doing those kinds of things. All right. So that's basically what's going on. Whoops, excuse me. Make a new page there. All right. So let's move on to the next problem. The next problem, we're going to use the same expenses on our data set. All right. But this time, instead of saying is there a correlation between the amount of money spent by a college wrestling program and how they placed at nationals in 2017, let's look at the amount of money spent and how many points each team scored. Okay, for those of you who are not familiar, basically the more points a team scores, the higher they place in nationals. So the placements we saw on the previous slide, we're going to look at expenses versus points scored at the national tournament on this slide. So go ahead now, just forewarning you, all of these institutions, we're still taking Big Ten schools. We still have all of their expenses that are exactly the same, and it should be all in the exact same order. All right. So the only thing we need to do is change the list 2. So all you have to do is change the list 2 values and see what happens there. So what I'd like you to do is once you get all of these input, all of the data input, then go ahead and find the least squares regression line, find the correlation coefficient. I apologize, let me put that up there. So once you've found that, find the least, or once you have that input, find the least squares regression line, find the lower correlation coefficient, ask yourself whether this is a good or a bad fit, and then try to predict the same as in the last example. So predict with what would happen at 1.5 million, predict what would happen at 2 million, and do those things. So I'm going to push pause on the video. I want you to calculate all that kind of stuff, find the least squares regression line, find the Pearson correlation coefficient, ask yourself whether this is a good or bad fit, and then do the predictions. Hopefully, you went ahead and did that, pushed pause and did all that kind of good stuff. I'm going to go through this fairly quickly. So we looked at the money and the points. The least squares regression line is y equals, well, in this case, again, we get scientific notation. That tends to happen when our data set has really big values for our x. Notice that each one of the teams spent in the millions. So if our x were small, our coefficients would be a little bit larger. So we have 8.41 times 10 to the negative fifth x minus 84.53. All right. The correlation coefficient that I got, R, was equal to 0.8681. So based on our judgment, since this R is bigger than 0.75 in terms of absolute value, we would say this is a good fit. All right. So for the sake of our class, this is a good fit. Now, if you wanted to predict what would happen when we spend 150 million, we're just going to take this exact same equation up here. Did I say 150 million? I apologize. Predict when we spend 1.5 million. Whew, big difference. We just put in 1.5 million in for the X. And what I end up with is a point total of 41.62. All right. So 41, so this line predicts that if a college team in the Big Ten were to have spent 1.5 million, they would have ended up with about 41.62 points in the national tournament. All right. Now, if a college were to have spent 2 million, all we're gonna do is replace that 150 million with 2 million. I keep saying 150 million. I apologize. 1.5 million with 2 million. And when you calculate that, you should end up with 83.67. So again, this you would say that this line predicts that if a college team were to have spent about $2 million, they would have ended up with about 83.67 points in the national tournament, all right, based on this data. So what that means is, yes, how much money a college spent on their program does affect how many points they score, and excuse me, the more money they spend, the more points they're going to score. All right. So there you go. Now let's go to another example. We're going to go to another example outside of college wrestling. So we're going to go to the Big Mac and happiness example that's in our notes. All right. This is for multiple purposes here. So we want to see if there's a correlation between a country's Big Mac index and their overall level of happiness. Data was collected for a sample of 11 countries, and we collect the Big Mac index. I think that is the 2016 Big Mac index, and the Cantrell ladder score, which is basically asks people to evaluate their quality of life on a scale of 0 to 10. All right. So as 10 being the highest quality of life, 0 being the least. And so what we have here is a sample of a bunch of different countries. We can see 1, 2, 3, 4, 5, 6, 7, 11 different countries here. And we see their Big Mac index and their Cantrell ladder score. Again, higher level means higher level of happiness. So higher numbers mean higher happiness. By the way, what's the Big Mac index mean? That's basically how much money you'd have to bring to that country in order to buy a Big Mac there. So in Canada, you'd have to bring about 5.25 US dollars. And when you do the currency exchange and then go into McDonald's, you could buy a Big Mac. You could buy a Big Mac in Mexico for a lot less money. Okay, so it takes into account a lot of things like the currency, excuse me, the currency exchange rates, plus how expensive things are in that country, and so on and so forth. So it is, by the way, look this up. You can actually look it up. Just Google it, Big Mac Index. You'll see what it's all about if you want to learn more. All right. All right. So I want you to put this data in, then try to find a least squares regression line based on the data. Find a correlation coefficient based on the data. Tell me whether the line is a good fit or a bad fit. And then let's use the line to predict the happiness level, in other words, the Cantrell ladder score, if the Big Mac index is at $3.06. All right? So go ahead and do that. Again, prediction is when the Big Mac index is at $3.06. Pause the video and then come back when you've done those things to check your answer. So hopefully you went ahead and did that. I'm going to switch over to the um, other notes. So when I did this, my least squares regression line came back as y equals 0.41x plus 5.06. And my Pearson correlation coefficient came back as 0.7790. It's actually 0.778975, blah, blah, blah. But when you round it to 4 decimal places, it goes to 0.7790. That 0.7790 is a good fit, right? So, or I should say, the number is not a good fit, but that means that the line is a good fit, all right? So the line is a good fit because of this correlation coefficient, which is fairly surprising. You wouldn't think there'd be some sort of a correlation between how much a Big Mac costs and the quality of life in a country. Although, again, you know, if you can get beef for cheap and you can get wheat for cheap, then it probably is a good sign for your country. All right. Or I should say, the cost of it as it goes up might be a good sign. Who knows? Who knows why that is? All right. This is actually saying that as the price of Big Macs go up, the quality of life is going up. The happiness level in a country is going up. So kind of a weird correlation going there. All right. Now, if we try to predict what this line would say about happiness, if the Big Mac index were $3.06, well, we'd go 0.41 times 3.06 plus 5.06 gives me 6.3146. So this line would predict 6.3146 to be the happiness level or the Cantrell ladder score if the Big Mac index were at $3.06. All right. So there you go. Now I noticed these first few examples 2, 3, and 4. I did not show you my calculator screen, but once again, it's stats calculate linear regression. All right, number 4 in the calculate menu. And you should be getting the line and the R. If you forget how to do that, if you have forgot how to do that, go back to the last video and check that out. I'll be flipping in the next example, flipping my screen on a couple of times to see that we have the right thing. All right. So, since the since the Big Mac index was a fairly good indicator of happiness level in a country, let's actually see if there's any correlation between the number of McDonald's restaurants per million people in a country and their overall level of happiness. So it's basically how many McDonald's restaurants there are per 1 million people in a country. All right. So we're going to take the same 11 countries and the same Cantrell ladder scores by default. But now my variable x, is going to be the number of McDonald's per million people. All right. So for instance, in the United States, we beat all other countries. There's almost 41 McDonald's per million people in the United States. Okay. Now I want you to go ahead and input that data, stats edit, give the least squares regression line, give the correlation coefficient, state if it's a good fit or not, and then use the line to predict the happiness level, in other words, the Cantrell ladder score, if the number of McDonald's per million people is at 18.4. So go ahead, push pause on the video, do all of that now. All right, so hopefully you went ahead and did that. We're going to look at, first off, what these things are, but also I'm going to make sure that we know where things are on our calculator. So first off, okay, when you're inputting data, we're going to go through this again fairly quickly. When you're inputting data, you're going to go edit, so you're going to hit stat, edit, you're going to hit enter, and then list one, you put all of your number of McDonald's per millions of people. In list 2, go ahead and put your happiness level based on the Cantrell ladder scores. Okay? Once you've done that, then what you're going to do is you're going to hit stat, scroll over to calculate, stat, calculate, and then hit the number 4 there. That's the linear regression. That's what your calculator should look like. Now, when you hit enter on this linear regression, you're going to get one of two screens. If your screen looks like this, then you're just going to hit L1, L2 right after the linear regression, and then go ahead and hit enter. All right, and then your screen will look like that. Now there's also the other mode on your calculator, which tells you, this is basically with the stats wizards placed on. And if you go into your linear regression, you'll see an X list, a Y list, a frequency list, and it says store regression equation. These are all things you can do. So in other words, if you go into if you have another mode on your calculator, if you have the stats wizards on, then it's going to look like this. You're going to put in L1 for your X list, L2 for your Y list, leave the frequency list blank, and then hit calculate. Now when you go ahead and do that, sure enough, you get the exact same display. So either way you do this, the display is going to be the exact same. Again, if you do not see this R, then what you have to do is you have to hit second and then 0, go into your catalog, and turn your diagnostics on. Just go to diagnostics on, hit enter twice. If you need to see that, then you can go to the previous video. All right. So number of McDonald's number of McDonald's, if we were trying to use this to predict happiness, it says that our least squares regression line would have been y equals 0.01x plus 6.66. Again, hopefully I typed that incorrectly. I didn't double check my math, but again, if I did make a mistake on any of this, let me know. On any of these videos, let me know. The correlation coefficient that I got, R, was 0.2164. Now that is a very small correlation coefficient. So this line is a bad fit. Now just let me explain what a bad correlation coefficient really is indicating. If you look at a scatter plot of this data where each of the McDonald's per million and the Cantrell ladder score is a ordered pair, an XY value, the graph that you're going to end up with, well, I can display it on my calculator. Don't worry, you're never going to be asked to display it on your calculator, but it looks like this, okay? And you can see that these dots are just basically randomly spread out all over this graph, all over the screen on our calculator. So it's not a very good, there doesn't seem to be any really nice pattern there. So with a correlation coefficient of 0.2, or I should say correlation coefficient of 0.2164, that again doesn't look like there's any pattern there. Now, we still made a line, right? Our equation still is there, so we can still use it to predict, although we know that it's going to not be a very good prediction. So if we want to use the line to predict, we can if it asks me, but in reality, we kind of know better. So use the line to predict. Basically, we just replace the x value with 18.4. I always go into my calculator and I just type in 0.01 times 18.4 plus 6.66. That gives me 6.844. So this line, although it's not a good fit, would predict us to have a happiness level, a Cantrell ladder score of 6.844. There you go. Again, in real life, you'd say, hey, there's no correlation here, so we'd kind of leave it alone. But on a test, on homework, we go ahead and do the prediction if it asks us to do that. So there you go. All right, so that shows the display screen. Now, I wanted to give you a way to cheat. All right, so we just saw that the number of McDonald's per million people is not correlated, and it's a really low R value. So it is not correlated to the happiness level in a country. However, I want to show how we can paint whatever narrative we want to if we're a little bit dubious. In other words, if we're willing to selectively ignore data we don't like and selectively focus on data that we do like, then obviously we can craft a narrative that backs up our point of view. Okay? So what we're gonna do is we're gonna selectively pick a couple of different subsets. All right? And this is the equivalent of me ignoring data that I don't like and accepting data that I do like. All right? We're going to go both sides of this. So let's say I wanted to paint a picture that the number of McDonald's per million people actually has a positive influence on happiness. What kind of a subset could I have picked? Or if I want to craft a narrative that says the number of McDonald's per million people has a negative influence on happiness, well, what sort of subsets could I have picked? All right. So here's what we do. Actually, let me back up one more time and talk about what we're actually doing graphically before I hit along. Basically, I said all these dots didn't look to be in a pattern. However, if I just pick a few dots, like this one and this one and this one, maybe if I only pick 3 or 4 of these, I can find a pattern. Maybe if I pick this, a few of those dots, maybe it looks like those dots are in a pattern. Maybe if I pick these ones, maybe it looks like those few are in a pattern. That's basically what I'm doing. I'm just picking the dots, a few of the dots that are in a pattern. So here's what I'd like you to do. I'd like you to do the exact same problem I just asked you, but on this subset of 4 countries. So we're going to look at just the Japan, Norway, Switzerland, and the UK examples. All right. So once again, find the least squares regression line, find the Pearson correlation coefficient, ask yourself whether this line is a good fit, and then predict the happiness level if the number of McDonald's per million people is 18.4. So notice again, exact same questions, exact same things that I asked earlier. So go ahead, push pause on the video, do all of those things, and then come back and check your answer. Hopefully you inputted all of that data and you came up with a least squares regression line. Okay, so let's take a look at what we came up with. So we had these 4 data points. My least squares regression line, the one I came up with, was y is equal to negative 0.11x plus 8.88. All right. I should have probably started a new page, but that's okay. All right. So y equals negative 0.11x plus 8.88 as my least squares regression line. My correlation coefficient R, since this is a negative slope, my R happens to be negative 0.9710. So this is not just a good fit. This is a very good fit in terms of that correlation coefficient. That correlation coefficient is very, very close in absolute value to 1. So it's a very good fit in this case. And if we use the line to predict, well, all we have to do is say y values were the happiness level based on the Cantor ladder score, and x was the number of McDonald's. So if our number of McDonald's per million people is 18.4, all I have to do is plug that in. So negative 0.11 times 18.4 plus 8.88. I type that into my calculator, and what I get is a y value. Whoops. I thought that was going to be the same size. Yep. A y value happiness level is 6.856. All right. So that's all the things that I asked you to do. Now there's one other question here. You can look at it on the PowerPoints, or you can look at it on the guided notes. That last question says, well, where should I not predict due to extrapolation? We know this is a good fit, but that doesn't mean I can predict everywhere, okay? Just because it's a good fit means that I can predict within the known bounds. So if I look at this example, 11.7 is my lowest x value, 28.4 is my highest x value. So 0, I should not predict that because that would be too low. 5, I should not predict that because that is too low. In this example, 10 is too low because that's below my 11.7. 15, 20, 25, those are all between 11.7 and 28. 30, well, that's above 28.4. That's above the highest value. So I can't predict at 30. And because I can't predict at 30, I can't predict anywhere above there either due to extrapolation. All right? Hopefully you can read that. But basically, I can't really circle the values, so I just highlighted those in red. So 0, 5, 10, 30, 35, and 40 are all values that you would not want to predict at due to extrapolation. Okay. Now, what does this line do? By just selecting this data, what this is saying is that we have a really good correlation, a really good pattern that shows within this sample that as the number of McDonald's per million people goes up, people get less happy, right? That's what this negative coefficient here. As X increases, as you increase the number of McDonald's per million people, people are getting less happy based on this data. So by looking at these 4 examples, I could craft a narrative that says more McDonald's makes people less happy. Okay? Now, let me just show you what happened there using the graphs. Basically, I want to highlight which points I picked out. So I have my original data here, circles in blue. You'll see that in red, in other words, the blue circles that are highlighted, that have little red dots in them, those were the 4 examples that I picked out. So if I'm willing to ignore, in other words, selectively ignore data from over here, any data that I don't like, and just focus on these 4 points that I do like, then I can craft a really good narrative that says the number of McDonald's per million people, as it goes up, people get less happy. In other words, as X increases, Y is decreasing. Okay, again, that's if I'm willing to selectively ignore data that I don't like and just look at the data that I do like. Well, see if I can craft a narrative on the other side of this too. So what I'd like you to do is I want you to look at example 7, do the exact same thing with the exact same numbers. So we're going to look at the least squares regression line, the Pearson correlation coefficient. We're going to state whether it's a good fit or a bad fit based on these 4. And then we're going to do the exact same prediction, predict the happiness level when the number of McDonald's per million people is 18.4. And then do the exact same extrapolation question from based on this data. All right, so push pause on the video, go ahead and do that, and come back with the answer. All right, so hopefully you went ahead and did that. I'm going to look at this on the guided notes. So that's where I'm going to fill these things in. The least squares regression line, let's actually make that a little bit smaller. y equals 0.03x plus 6.41. Again, rounding to 2 decimal places. The correlation coefficient, R, is 0.9937. Again, that is a very good fit, okay? A very good fit. So, there we go. Notice this fit, though, or excuse me, notice this line paints a very different narrative. This is saying, since this coefficient is positive, since what this is saying is that if you increase the number of McDonald's per million, excuse me, if you increase the number of McDonald's per million people, then the Cantor ladder score, the happiness level goes up, all right? Notice that was the exact opposite narrative that we had based on the last example. So if I'm selectively choosing data, selectively choosing these four data points to look at, or these four countries to look at, paints a very different picture than these first four countries. These first four countries showed that as you increase the number of McDonald's, happiness level goes down. I can selectively look at this and say, well, you increase the number of McDonald's, happiness score goes up. And it's a really good fit. In our last problem, we had a really good fit too. All right. Now, if we wanted to predict the happiness level here, we're doing the exact same thing as we always do. We just substitute the letter X with 18.4. So 0.03 times 18.4 plus 6.41 gives me a 6.962. All right, so Y equals 6.962. Now the last problem, last part of this problem says circle all values which we should not predict due to extrapolation. Well, in this case, notice that the number of McDonald's per million people, the lowest value is 1.8, the highest value is 33.9. So anywhere between 1.8 and 33.9, I'm okay. What would that be? Well, 5, 10, 15, 20, 25, and 30 are all okay this time. 0 is not okay. That's too low. 35 is too high. And 40 is also too high. All right? So notice that because my x values went from 1.8 to 33.9, on this one, we didn't have to circle as many values where we can't predict. Okay? So again, what do these two back-to-back examples tell us? Well, they tell us that first, if we're willing to selectively pick which data we want to look at, then we can paint any story we want to, right? If we're willing to ignore data that we don't like and just focus on the data that kind of already confirms our own biases, then shoot, we can come up with anything, all right? This is why it's so important to have good samples, to have our samples being actually representative of the population. We want randomly picked samples. We want, very good sampling techniques done. That way we can avoid, just focusing on data that we like and throwing away data that we don't like, okay? So it's very important that we get the right samples. The other thing that this shows is that, well, you can paint any story you want to with anecdotes. All right. If you want to look at 4 countries or just a couple of countries, you can come up with nearly any conclusion that you want if you're just willing to pick out a few examples. All right. This is why statistics, again, properly done, is going to beat anecdotes every time. Okay. Because it allows us to take away our own biases. It allows us to look at the data free of, our own sort of opinions of it. Okay? So statistics properly done beats anecdotes every time. And if you went up to somebody and you told them something about McDonald's, well, if they really like McDonald's, they'd probably be inclined to believe example 7. If they really disliked McDonald's, they'd probably be inclined to believe example 6. Whereas statistics says we should have looked at example 5. We should have compared all of these countries and seen that, you know what, there really isn't any sort of correlation going on between how many McDonald's a country has and the level of happiness in that country. So, again, this is why statistics beats anecdotes. It can sort of pull our own biases out and let us focus on really what's going on in a bigger group. Okay? So, statistics beats anecdotes every time. You can paint any picture you want with anecdotes, statistics a little bit harder. So, that concludes the course and chapter 12. Hopefully, it's been good, and I hope that you have a really good final.